trigonometric identity proofs. So here we're going to look at all the trigonometric identities we've discovered so far and use them to prove if equations are true or false. So we've got sine squared x plus cos squared x equals 1, 1 plus cot squared x equals cosec squared x, tan squared x plus 1 equals sec squared x. We're going to use cot x equals cos x over sin x, tan x equals sin x over cos x, sin x equals 1 over cosec x, cos x equals 1 over sec x, cot x equals 1 over tan x, cosec x equals 1 over sin x, sec x equals 1 over cos x, and tan x equals 1 over cot x. So using all these, I will be able to manipulate equations and prove if they're true or not. So I'm going to look at our first one. We're required to prove that sec x plus tan x equals 1 plus sin x over cos x. Now with these, you can actually choose which side to deal with, either the left or the right, and manipulate it to try and make it look like the other side. My strategy is whatever side doesn't have sines and coses, that's the side I try and manipulate. So in this case, it'll be the left-hand side, because the right-hand side already has sines and coses. And my strategy is usually to change everything into sines and coses, because using all of these identities, everything can be changed in terms of sine and cos. So that's exactly what we're going to do. We're going to take the left-hand side, which is sec x plus tan x, and we're going to try and turn it into the right-hand side by using the strategy to change everything into sines and coses. So sec x is actually 1 over cos x, and tan x is sin x over cos x. So we've successfully changed everything to sines and coses. And now our denominators are the same, so we just have to add our numerators together and we actually get that right hand side. So we can say therefore the left hand side equals the right hand side. So let's look at a more difficult example. So in this one we're required to prove that 1 plus cot x over cosec x minus sec x over tan x plus cot x equals cos x. So obviously we're going to take the left-hand side because the right-hand side is just cos x, and we're going to change everything into sines and coses. So it's going to be 1 plus cot x, we can write as cos x over sin x, all over cosec x, which we can write as 1 over sin x, minus sec x, which is just 1 over cos x, all over tan x, which is sin x over cos x, plus cot x, which is cos x over sin x. So we successfully change everything into sines and coses, and we have a bunch of fractions here that are being added and subtracted all over the place, and we need to bring all these together. So we're going to start by bringing those together and those together. So a really helpful trick when you're adding 1 with a fraction is to look at the denominator of the fraction and make the 1 that denominator over itself. So the 1 I can write as sin x over sin x, because now they have the same denominator and I can easily add those together. So denominator we keep the same and we just add the numerators. So we get sine x plus cos x in the numerator. And that's all over 1 over sine x minus 1 over cos x all over. Now, to add these fractions together, we need the same denominator. So to do that, we might times this numerator by sine x over, and the denominator by sine x, and this one by cos x over cos x, because that'll make both denominators sine times cos. So if we do that, we're going to have our denominator of sine x times cos x, and sine times sine is sine squared x, plus cos times cos is cos squared x. So now we just have a fraction over a fraction minus a fraction over a fraction. So a really good trick is when you have a fraction over a fraction, so we have a over b all over c over d, is it's the outer two over the inner two multiplied by each other. So it becomes AD over BC. So we're going to apply that. And try not to expand them straight away. So just write them. So we're going to do the outer over the inner and the outer over the inner, but we're going to leave them expanded. So the outer ones multiplied is sine x multiplied by sine x plus cos x over the inner two multiplied together, or 1 times sine x is just sine x, minus the outer two multiplied together here gives us sine x times cos x over, now sine squared x plus cos squared x, well we know the identity that actually equals 1. So it's just 1 times cos x, which gives us cos x. And the reason we don't expand is because, yeah, sometimes we can simplify these. So let's go ahead and do that. So sine x and sine x will cancel out, and cos x with cos x will cancel out, which just leaves us with sine x plus cos x minus sine x, and sine x minus sine x goes, and that just gives us cos x, which equals our right-hand side. So we can say, therefore, the left-hand side equals the right-hand side.